Jevons Paradox, a comprehensive overview. Introduction. Jevons Paradox, named after the English economist William Stanley Jevons, encapsulates a counterintuitive phenomenon in economics. Improvements in resource efficiency can lead to an overall increase in resource consumption. This paradox is particularly relevant in discussions about energy efficiency and sustainability, raising critical questions about the effectiveness of efficiency-focused policies in mitigating resource depletion and environmental degradation. Historical context. The concept of Jevons paradox was first articulated by William Stanley Jevons in his 1865 work, The Coal Question. Jevons observed that enhancements in the efficiency of coal use, particularly following the introduction of the Watt steam engine, resulted in increased, not decreased, total coal consumption. He famously stated, "It is a confusion of ideas to suppose that the economical use of fuel is equivalent to diminished consumption. The very contrary is the truth." This observation highlighted the relationship between efficiency improvements and demand, laying the groundwork for future economic analyses of resource use. Core mechanism of Jevons paradox. 1. Efficiency and cost dynamics. When technology improves efficiency, the cost of utilizing a resource effectively decreases. This reduction in cost can stimulate demand as consumers and businesses take advantage of the lower costs to increase usage. For example, a more fuel-efficient vehicle costs less to operate, which may encourage people to drive more often or for longer distances, thus increasing overall fuel consumption. 2. The rebound effect. The rebound effect refers to the phenomenon where gains in efficiency lead to an increase in resource consumption that offsets the intended savings. If the increase in demand due to lower costs exceeds the savings achieved through efficiency, total consumption rises. Exemplifying Jevons paradox. 3. Price elasticity of demand. The extent of the rebound effect is influenced by the price elasticity of demand for the resource in question. If demand is elastic, a small decrease in the price due to increased efficiency can lead to a significant increase in quantity demanded. Conversely, if demand is inelastic, the increase in consumption may be minimal. Khazzoom, Brookes postulate. In the 1980s, economists Daniel Khazzoom and Leonard Brookes revisited Jevons paradox, introducing the Khazzoom-Brookes postulate. This hypothesis posits that improvements in energy efficiency result in an overall increase in energy consumption, primarily due to the increased economic activity they foster. Harry Saunders later expanded on this postulate, linking it to neoclassical growth theory and emphasizing that while macroeconomic effects may show reduced energy consumption, macroeconomic growth tends to increase energy use. Policy implications. The implications of Jevons paradox are profound for energy conservation strategies and broader environmental policies. 1. Efficiency alone is insufficient. Many policymakers assume that improving resource efficiency will automatically reduce consumption. However, Jevons paradox suggests that without additional measures such as regulations or taxes that increase the cost of resource use, efficiency improvements may not lead to the desired reduction in consumption. 2. Coupling efficiency with conservation policies. To mitigate the rebound effect, economists advocate for coupling efficiency improvements with policies that discourage consumption. Options include green taxes, cap-and-trade systems, and stricter emissions standards. These measures can help ensure that efficiency gains do not lead to an overall increase in consumption. 3. Case studies beyond energy. The principles of Jevons paradox extend beyond energy consumption to other resources, including water and materials. For example, improvements in irrigation efficiency may lead to increased agricultural output, prompting farmers to cultivate more land, thereby increasing overall water usage. 4. Contemporary applications. The rise of artificial intelligence (AI) serves as a modern illustration of Jevons paradox. As AI technologies become more efficient and accessible, their demand is expected to surge, potentially leading to increased resource consumption across various sectors despite the initial efficiency gains. Ongoing debates and research. The relevance of Jevons paradox and its implications for sustainability remains subjects of significant debate among economists and environmentalists. While some argue that the paradox undermines the effectiveness of efficiency policies, others maintain that it highlights the need for a more nuanced understanding of consumption dynamics. Empirical evidence regarding the magnitude of the rebound effect remains mixed, with some studies suggesting that the effect is often less than 100%. Allowing for net savings in resource use at the microeconomic level. Conclusion: Jevons paradox presents a critical lens through which to view the relationship between efficiency consumption and environmental sustainability. Understanding this paradox is essential for developing effective policies that not only promote technological advancements but also ensure that such advancements contribute to genuine reductions in resource consumption. As discussions around sustainability and resource management continue to evolve, the lessons of Jevons paradox will remain vital in shaping future strategies. By recognizing the limitations of efficiency improvements when considered in isolation and advocating for comprehensive policies that address consumption behavior, societies can better navigate the challenges of resource depletion and environmental degradation. Counterintuitive information in Jevons paradox. 1. Efficiency leads to increased consumption. At first glance, one would assume that improving the efficiency of resource use would naturally lead to a decrease in overall consumption of that resource. However, Jevons paradox illustrates that when resources are used more efficiently, their effective cost decreases, which can actually stimulate increased demand and subsequently higher overall consumption. This contradicts the intuitive belief that conservation and efficiency automatically reduce resource use. 2. Rebound effect. The rebound effect, a key component of the Jevons paradox, demonstrates that consumers often increase their usage of a resource when it becomes cheaper due to improved efficiency. For example, if a vehicle becomes more fuel efficient, consumers might choose to drive more or take longer trips, leading to an increase in total fuel consumption. This counterintuitive behavior contradicts the expectation that greater efficiency would simply lead to lower consumption. 3. Khazzoom or Brookes postulate. This postulate extends the implications of the Jevons paradox, suggesting that overall energy consumption will rise as efficiency improves, not just in individual markets but across the economy as a whole. This challenges the conventional wisdom that pursuing efficiency will inherently lead to reduced energy consumption and environmental benefits. For economic growth correlation, the paradox suggests that increased efficiency can lead to greater economic growth, which in turn increases demand for resources. This challenges the assumption that it is possible to decouple economic growth from resource consumption solely through efficiency improvements. 5. Policy implications. Many policymakers assume that promoting energy efficiency will automatically lead to lower resource consumption and reduced environmental impact. However, the Jevons paradox indicates that without complementary measures, such as taxation or regulations that limit consumption, efficiency gains may result in higher overall usage, which is counterproductive to sustainability goals. 6. Application beyond energy. The paradox is not limited to energy resources. Its implications can be applied to various sectors, including water usage and even technologies like artificial intelligence. For instance, as AI becomes more efficient, the demand for its use is expected to surge, leading to an overall increase in resource consumption. This broad applicability challenges the notion that efficiency gains in any sector will straightforwardly lead to reduced resource use. 7. Historical context. Jevons' original observations about coal consumption during the Industrial Revolution reveal a historical pattern where technological advancements, rather than conserving resources, have often led to increased overall consumption. His assertion that the economical use of fuel is equivalent to diminished consumption highlights the reversal of expected outcomes in the context of resource consumption. 8. Environmental dilemma. The Jevons paradox raises an uncomfortable dilemma for environmentalists. Efforts to improve efficiency may inadvertently contribute to more rapid depletion of resources and increased environmental degradation. This counterintuitive outcome places efficiency strategies in a complex light, suggesting that they alone cannot solve environmental issues without additional regulatory frameworks. 9. Empirical evidence debate. While some economists argue that the Jevons paradox is not universally applicable, the ongoing debates and studies surrounding its relevance indicate that the relationship between efficiency and consumption is more nuanced than previously thought. This challenges the assumption that efficiency improvements will always lead to reduced resource use. 10. Behavioral economics. The behavioral aspect of the Jevons paradox suggests that consumer behavior does not align with rational economic models. People may not reduce consumption simply because a resource becomes cheaper or more efficient due to psychological factors and social norms that influence their decisions. In conclusion, Jevons paradox reveals several layers of counterintuitive insights regarding resource efficiency and consumption dynamics, challenging conventional beliefs about conservation strategies and highlighting the complexities of economic behaviors in the context of sustainability. The Jevons paradox is a fascinating and critical concept in the study of resource consumption and environmental economics, often overlooked in discussions about sustainability and efficiency. Here are some important aspects of the paradox that are significant yet frequently missed. 1. Historical context and misinterpretation. The paradox was first articulated by William Stanley Jevons in his 1865 work, The Coal Question. Many people misinterpret Jevons' observation as a straightforward warning against energy efficiency improvements. In reality, Jevons was addressing a broader concern about the unsustainable extraction of resources in the context of industrialization. The significance of this historical context is often lost, leading to a simplistic view that simply equates efficiency with sustainability. Understanding the historical context of Jevons' work is crucial because it illustrates the complexities surrounding resource use and the assumptions made about technological progress. 2. The rebound effect and its complexity. The rebound effect is often cited as a mechanism behind the Jevons paradox, where increased efficiency leads to lower costs and consequently higher consumption. However, many discussions fail to explore the various factors that influence the magnitude of the rebound effect, such as the price elasticity of demand, consumer behavior, and market conditions. This complexity is significant because it implies that the rebound effect is not uniform across all contexts and resources. Different consumer responses can lead to vastly different outcomes, which policymakers must consider when designing energy efficiency programs. 3. Policy implications. The paradox raises critical questions about the efficacy of efficiency-focused policies in achieving sustainability. Many policymakers assume that improving energy efficiency will automatically lead to reduced consumption. However, Jevons' paradox suggests that without complementary measures such as taxes or regulations that increase costs or limit resource use, efficiency gains may lead to increased overall consumption. This insight is often overlooked in policy discussions, where a focus on efficiency can overshadow the need for comprehensive strategies to manage demand. 4. Cross-domain applications. Although often discussed in the context of energy, the Jevons paradox applies to various resources, including water, land, and even digital resources like computing power. For instance, in agriculture, increasing crop yields can lead to expanded farmland as farmers seek to capitalize on efficiency gains. This cross-domain applicability is significant because it highlights the need for a more holistic understanding of resource management and the unintended consequences of efficiency improvements across sectors. 5. Emerging technologies and AI. With advancements in technology, particularly in artificial intelligence, the Jevons paradox is becoming increasingly relevant. As AI becomes more efficient and accessible, its demand is likely to skyrocket, potentially leading to increased resource consumption rather than reductions. This contemporary application of the paradox is often overlooked in discussions about the digital economy and sustainability. It emphasizes the need for foresight and caution in the deployment of emerging technologies, ensuring that efficiency gains do not inadvertently exacerbate resource depletion. 6. The role of behavioral economics. Behavioral economics can provide insights into how consumers react to efficiency gains. For instance, the psychological factors affecting consumer behavior, such as perceived savings or the status associated with using efficient technologies, can influence consumption patterns. This behavioral aspect is often neglected in discussions about the Jevons Paradox, despite its significance in shaping real-world outcomes. Understanding these dynamics can help in crafting more effective policies that account for human behavior rather than relying solely on technical efficiency improvements. 7. Environmental justice considerations. The implications of the Jevons Paradox extend into the realm of environmental justice. Efficiency gains may disproportionately benefit certain populations while exacerbating resource depletion in others. For instance, wealthier communities may leverage efficiency technologies to increase consumption without regard for sustainability, while marginalized communities may bear the brunt of resource scarcity. This aspect is often overlooked in discussions about sustainability and resource management, which can lead to inequitable outcomes. 8. Long-term versus short-term perspectives. Short-term thinking often dominates discussions about efficiency improvements with a focus on immediate gains rather than long-term sustainability. The Jevons Paradox serves as a reminder that improving efficiency today can lead to increased consumption tomorrow, potentially undermining long-term resource management goals. This is particularly significant as societies grapple with challenges like climate change and resource depletion, where long-term sustainability should be prioritized over short-term efficiency gains. In conclusion, the Jevons Paradox is a complex and multifaceted phenomenon that carries significant implications for resource management and sustainability policy. By recognizing and addressing the often overlooked aspects of this paradox, such as historical context, the complexity of the rebound effect, and the need for comprehensive policy measures, society can better navigate the challenges of resource consumption in an increasingly efficiency-driven world. Understanding these nuances is crucial for developing effective strategies that truly promote sustainability rather than merely shifting consumption patterns. 1. Understanding the rebound effect. The Jevons Paradox is fundamentally linked to the concept of the rebound effect, where increased efficiency in resource use leads to a decrease in costs, thus stimulating higher demand for that resource. This phenomenon can result in total consumption rising despite individual consumption per unit declining. For example, if a car becomes more fuel efficient, the cost per mile decreases, which may encourage more driving, ultimately leading to increased fuel consumption. Analyzing the dynamics of this rebound effect is crucial for developing effective energy policies and understanding consumer behavior. 2. Khazzoom or Brookes postulate. This postulate extends the Jevons Paradox by asserting that improvements in energy efficiency will lead to increased overall energy consumption at a macroeconomic level. This is due to the dual effects of lower operational costs encouraging greater utilization of energy resources and the increase in real incomes that spur economic growth. The Khazzoom-Brookes postulate emphasizes the need to consider not just the microeconomic effects of efficiency improvements but also the broader economic implications, suggesting that simply improving efficiency may not yield the desired reductions in energy consumption without additional policy measures. 3. Policy implications and strategies for resource conservation. The Jevons Paradox poses significant challenges for energy conservation strategies. While many policies focus on promoting efficiency as a means to reduce consumption, the paradox suggests that without additional measures such as taxes or regulations that raise costs, efficiency gains may lead to increased consumption overall. Hence, effective policy strategies must couple efficiency improvements with mechanisms that control demand, such as green taxes or cap-and-trade systems, to mitigate the rebound effect and ensure sustainable resource use. For applications beyond energy resources, the implications of the Jevons Paradox extend beyond energy consumption to various resources such as water, land, and even technology. For instance, increased agricultural efficiency may lead to greater land conversion for crop production, thus increasing overall land use. In the realm of technology, advancements in artificial intelligence could lead to higher demand as systems become more efficient and accessible. Understanding the broader applications of the Jevons paradox allows for a comprehensive analysis of sustainability challenges across multiple sectors, highlighting the need for integrated resource management approaches. 1. The tragedy of the commons. Coined by Garrett Hardin in 1833, this concept describes a situation where individuals acting independently according to their self-interest deplete a shared resource, ultimately harming the collective good. The paradox arises when individuals are incentivized to maximize their own benefits, leading to overexploitation of resources like fisheries, forests, or grazing land. Despite the availability of sustainable practices, the lack of regulation or collective action results in depletion. Much like how increased efficiency, as described in Jevons paradox, can lead to greater consumption of resources instead of conservation. 2. The downside of technological advancement. The introduction of more efficient technologies in various sectors can lead to unintended consequences similar to Jevons paradox. For instance, the invention of the automobile led to increased travel and urban sprawl rather than reduced travel times and congestion. While cars became more fuel efficient over time, the overall miles driven increased, exacerbating traffic issues and pollution. This reflects how technological improvements can create a rebound effect where efficiency leads to increased demand and consumption rather than the expected decrease. 3. The iron law of oligarchy. Developed by Robert Michaels in 1911, this principle suggests that organizations inevitably develop bureaucratic structures that concentrate power in a few individuals, leading to inefficiencies and reduced democratic participation. While organizations may initially be designed to promote efficiency and equitable decision-making, the resulting concentration of power can lead to stagnation and inefficiency, similar to how improvements in efficiency can paradoxically result in greater overall consumption of resources. In both cases, the original goals are undermined by systemic changes that arise from the initial improvements. The Jevons paradox, first identified by William Stanley Jevons in 1865, illustrates a counterintuitive outcome of increased resource efficiency. Enhancements in efficiency can lead to greater overall consumption of that resource instead of less. As we look to the future, particularly in the context of sustainability, energy policy, and technological advancements, several key trends and predictions can be made regarding the implications of this paradox. 1. Technological advancements and consumption dynamics. As technology continues to advance, our ability to use resources more efficiently will likely increase. However, this will not automatically translate into reduced consumption. For instance, with the rise of electric vehicles (EVs), while they are more energy efficient than traditional combustion engines, the increased affordability and availability of EVs may lead to greater overall vehicle miles traveled. The Jevons paradox suggests that as technologies become cheaper and more efficient, they may incentivize higher levels of consumption across various sectors, including transportation, heating, and manufacturing. 2. The role of economic growth. Economic growth will continue to play a pivotal role in resource consumption. As countries develop and incomes rise, the demand for energy and natural resources tends to increase. The Khazzoom-Brookes postulate posits that improvements in energy efficiency could lead to increased overall energy consumption due to economic expansion. As emerging economies grow, if they adopt more efficient technologies without implementing policies to control demand, global resource consumption could escalate. 3. Policy interventions and regulation. To mitigate the effects of the Jevons paradox, future energy policies will need to be more comprehensive. Governments may increasingly implement regulations that pair efficiency gains with measures to control demand. For instance, carbon pricing, green taxes, and cap-and-trade systems could be employed to ensure that efficiency improvements do not lead to a net increase in consumption. Policymakers will need to adopt a holistic approach that considers both the benefits of efficiency and the potential for increased consumption. 4. Public awareness and behavioral change. As awareness of environmental issues grows, public sentiment may shift toward more sustainable consumption practices. Future campaigns could focus on the importance of not just efficiency but also conservation. Encouraging behavioral changes such as reducing overall consumption and embracing a circular economy will be crucial in counteracting the rebound effects associated with efficiency gains. Educational initiatives may help consumers understand the implications of the Jevons Paradox and promote sustainable choices. 5. Sector-specific implications. Different sectors will experience the Jevons Paradox uniquely. In agriculture, for example, improved crop yields through advanced biotechnology might lead to expanded farming areas and increased total land use. In technology, as computing power becomes more efficient, applications that consume more resources like AI and machine learning will become more prevalent. Therefore, sector-specific strategies will be necessary to manage the rebound effect effectively. 6. The influence of artificial intelligence. The rise of AI and automation could exacerbate the Jevons Paradox. As AI becomes more efficient and accessible, its use is expected to skyrocket, potentially leading to increased consumption of energy and computational resources. Companies may prioritize efficiency in production and logistics. But this could lead to a greater demand for energy to support larger-scale operations. The challenge will be to implement AI in ways that enhance productivity without leading to disproportionate increases in resource consumption. 7. Environmental and social equity considerations. The impact of the Jevons Paradox raises concerns about environmental justice and social equity. As efficiency technologies proliferate, there is a risk that benefits may not be equitably distributed. Wealthier populations may consume more due to increased efficiency, while marginalized communities could bear the brunt of environmental degradation. Future policies must ensure that efficiency gains contribute to a more equitable distribution of resources and environmental benefits. 8. Global cooperation and sustainable development. Addressing the Jevons Paradox will require global cooperation, particularly in mitigating climate change. International agreements and commitments will become increasingly important to manage resource consumption on a global scale. Countries will need to collaborate on sharing best practices, technologies, and policies that effectively balance efficiency with sustainable consumption. Conclusion. The future outlook regarding the Jevons Paradox is complex and multifaceted. While technological advancements will continue to improve resource efficiency, the implications for overall consumption and sustainability will require careful consideration. Policymakers, businesses, and consumers must work together to create strategies that recognize the potential for increased consumption while promoting sustainable practices. By acknowledging the lessons of the Jevons Paradox, we can better navigate the challenges of resource management in an increasingly resource-constrained world.